Professor Lin from the UH Fashion Design and Merchandising program has developed 3 different reusable masks which we share the construction methods on in the following videos.
All 3 patents can be downloaded from the Fashion Design and Merchandising website.
Pictures are demonstrated by FDM fashion instructor Miss Minako McCarthy with FDM No. 1 mask over medical mask. Here is the pattern for the FDM No. 1 reusable mask. It is a simple rectangle shape that is 8 by 15 inches. There is also a larger size available online that is 9.5 by 16 inches. Material for the FDM No. 1 reusable mask: 1 piece of rectangular fabric, 8 by 15 inches, 2 6-inch pieces of elastic, bias binding fabric, and a nose bridge, which you can use reusable twist ties or recycle from an old face mask. Here you will fold your piece of fabric in half and create a press assist guided rule, which is 3/4 of an inch wide and 18 inches long. In the middle, you will cut a 1/8 inch hole 8 inches long, as you can see in the picture. Here, you will take your piece of fabric and fold the fabric in half with your press assist guided rule. Create your first pleat 2 inches from the fold line. You may use the press assist guided rule to help create the pleat by placing the press assist guided rule and folding the piece of fabric into the empty hole. Use the press assist guided rule to make your second and third pleats by folding the fabric into the empty hole. These pleats will be ½ inch or 3/4 inch. After you've created your pleats, you will stitch both sides to secure the pleats in place. You might see a 3D effect, but it's okay. To fit the mouth, it is okay to have that effect. To make a pocket for your filter, fold and press down inside the edges into each other.
So those 2 top, both ends can be either 3/4 to stitch on the ends, and then when you fold on each other, and then create a pocket.
Here you will take your 2 6-inch pieces of elastic and secure them onto each end of the mask on the top and bottom of the mask. Here is an image of the mask with elastic attached on both ends. Here, you will apply the bias tape to secure the edges of the mask. For beginner sewers, you can use a pin to secure the bias tape in place and then begin stitching. Here you will insert a nose bridge into the mask, which will be hand stitched into place. You can reuse a nose bridge from an old mask or use a grocery store wrap or gift wrapping.
For the filter selection, there's so many options. You may select medical mask, use Melbro filter. It will last for 8 hours if you intensive use. Or you can just insert a medical mask to this big mask.
It is suggested to have at least 3 masks to alter use in between cleaning. Here we will explain the materials used for medical masks to help you better understand what materials would be best for you. For the outside layer, we use polypropylene, which has a hydrophobic effect, which repels water. Polypropylene with the hydrophobic effect is much more rigid and harder than PE and tends to hold up well under repeated use.
For the medical mask, we don't want you to select waterproof because waterproof, we need to have a breathable. The waterproof, sometimes they have a hard time to go the air through.
Here is the melt-blown non-woven or NB material that is a electrostatic registration filter used for the interlining layer of the mask. Melt blowing is a conventional fabrication method of micro nanofibers where a polymer melt is extruded through small nozzles surrounded by high-speed blowing gas. The randomly deposited fibers form a non-woven sheet product applicable for filtration, sorbents, apparels, and drug delivery systems. The substantial benefits of melt blowing are simply high specific productivity and solvent-free operation. Choosing an appropriate combination of polymers with the optimized rheological and surface properties, scientists have been able to produce melt-blown fibers with an average diameter of down to 36 nanometers.
You may find those air condition filter or vacuum filter. They are pretty much from this kind of materials.
For the innermost layer of the mask that is closest to the skin, we recommend using polyethylene, which is a hydrophile fabric, which is light and strong. Here we have a non-woven tea bag as an example. Hydrophile is a molecule or another molecular entity that is attracted to water molecules and tends to be dissolved by water. In contrast, hydrophobes are not attracted to water and may seem to be repelled by it.
Yeah.
Here we explain the difference between hydrophilic and hydrophobic surface and how they react to contact angles, adhesiveness, and wettability.
The example one is from the tea bag, or the other one is from the shopping bag, or the shell of the ski wheel.
Here is a list of household materials and their effectiveness against 1 micron particles, a report from Cambridge University. Just as the last report from Cambridge University, this list shares with us household materials and their effectiveness against 0.02 micron particles. Here we see that surgical masks are 89% effective, vacuum cleaner bags are 86% effective, dish towels are 73%, cotton blends 70%, An antimicrobial pillowcase is 68%, linen 62%, pillowcase 57%, silk 54%, 100% cotton t-shirt 51%, and a scarf is 49%. The table here shows the effectiveness of double layering masks. Here we see a surgical mask is 97% effective. A dish towel in 2 layers is 97% effective as well, whereas one dish towel is only 83% effective.
But the t-shirt only up 1.2%, even they create a double. So t-shirt did not have that much increase by using double. Male bro non-woven with electrostatics can be impact their effective.
This graph shows that melt-blown fabric without treatment is 37.25% effective, whereas melt-blown fabric with electrical treatment is 96.44% effective, and melt-blown fabric with water and electrical treatments are 99.98% effective. Here we see research suggests that melt-blown materials effectiveness against 0.3 micron with 40% to 2.5 micron particles and 95% with electrostatic assisted melt blown can be higher. Now you can select what materials would be best for your environment to create a mask.
Be safe. Happy making mask.